Welcome to Stats Part 2. Between this video and my Part 1 video, you should have everything that you need to know to do well on the stats questions for the DAT, so pay attention and learn this stuff. We're going to cover median, mode, range, standard deviation, and also mean, and then we're going to hit combinations and permutations. Median is the middle number. So the way that you solve for the median is by arranging the numbers in numerical order and then finding what number is in the middle. So if there's an odd number of terms, the median is just whatever number's in the middle. When there's an even number of terms, you'll have two different numbers in the middle, and so you just need to take the average of those two middle numbers. So for example, this set of numbers, what would be the median? Pause the video and figure it out. Hopefully you got 33. If you didn't get 33, you probably forgot to arrange the numbers in numerical order first, lowest to highest. But I'll show you how we got it. So first we organize them, smallest to largest. And then what I do is just cross out the outside numbers. Or I'll even just use my fingers and literally cover them up as I come to the center to figure out what's in the middle. And so we just X out each side till we hit the middle. And look at that, the median, 33. So let's do, all right, one more. What's the median of this set of numbers? First, you start with the same first step and get these numbers in order. And then cross out the outside numbers till you get to the middle. Okay, we reached the middle, and like we said earlier, there's two numbers in the middle for this one because this is an even number. So now we just take the average of those two numbers. And whichever is easier for you, you can either add them together and divide it by 2, or just use logic to figure out what number's in the middle of those two. But whichever method you prefer works fine, and you get 34.5. There we go. Next definition is mode. The mode is just the number that shows up the most often. So in this data set, the mode would be 3, because it appears the most. It's possible to have multiple modes in a single data set. For example, if we got rid of one of these 3, like that, now the mode is 3 and 5. They're both the most. Next definition, range. The range is the difference between the largest and smallest numbers. So for the range, don't waste your time organizing it smallest to largest. Just look at the list and say which number is the smallest, which number is the largest. And then you just subtract the smallest from the largest. So for this set of numbers, we would just do 20 minus 3, which is 17. The next definition is mean, which is just the average. And the way that you find the average is by adding up all the numbers in your list and divide that total by how many numbers there are. Then I also included at the bottom here these symbols for mean. The left symbol is called mu, and that just means the average. And then on the right, you have the X with the little line over the top. I actually don't know if there's a name for that, but that also means average. All right, this is where the video gets a little trickier. So stand up, stretch, wake up, do whatever you need to do, because now you're going to need to focus up. The technical definition of standard deviation is that it measures the dispersion of a set of numbers around the mean. In normal people terms, the standard deviation just tells us how spread out the numbers are. And the symbol for standard deviation is that little O looking thing right in the middle of the screen called sigma. It's a lowercase sigma. And the way that you find the standard deviation is with this very intimidating equation. Boom. That thing looks terrifying, right? But it's not actually bad once you know what the symbols mean and we work through it. So let's do that. So like we mentioned in the last slide, that little O on the left side of the equation is the sign for standard deviation. It's the lowercase sigma. That equals the square root of all this junk. The funky looking E there is an uppercase sigma. You may have heard the term summation before. That's what the symbol means. You just add up all the stuff that follows the sign. Then xi or x sub I is each number of your data set. So each number in your list that you've got there. Then hopefully you recognize mu. That's the symbol for mean or average. And then finally that n on the bottom stands for the amount of numbers in your data set. Let's do an example. I think that'll help make this make more sense. So find the standard deviation of this data set. First thing we should do is figure out what each symbol is. So xi is each individual number in the data set, right? So x1 is 4, x2 is 6, x3 is 11. Then mu is the average, so we just calculate the average out. We take 4 plus 6 plus 11 divided by 3, which equals 21 over 3, which equals 7. And n is the number of data points, so that's 3, and so that's 3. Now I'll show you how to plug it all in. Can you see how we got there? So remember that summation thing means that we're adding these all together. So we are doing x1 minus mu squared, and then summation, so we're plus x2 minus mu squared plus x3 minus mu squared. That's probably the most confusing part of all this. But if you can see how we got here, that's the hard part. And then obviously we divide that by 3 and take the square root. So simplifying some of this down, we get to the square root of 9 plus 1 plus 16 over 3, which is the square root of 26 over 3, which is about 2.94. So quick recap of what we actually did. We identified that x1, x2, x3 are our data points. Then you calculate the mean by adding up the 3 data points and then dividing by 3. And that gave us a mean of 7. And then we saw that the number of points is 3. And then you plug it all in. Now, luckily, you rarely are going to need to use this formula. They absolutely could ask you to do this, which is why we're covering it. But more often than not, they're just going to require you to understand what standard deviation is. And so again, the standard deviation is a measurement of how spread out the numbers are in the data set. The smaller the standard deviation, the closer the data points are to each other. The other part of standard deviation that they might test you on is this rule, the 68, 95, 99.7 rule. In a normal distribution bell curve, the standard deviation allows us to predict how the data will fall around the average. So I'll show you a picture of what that means here in a second on the next slide, but the rule states that 68% will fall within 1 standard deviation, 95% will fall within 2 standard deviations, and 99.7% will fall within 3 standard deviations. So here's the picture. So this is a bell curve or a normal distribution. So you can look at this graph and commit it to memory, but some things to note. This is what we were talking about. So this is the center, this is the average right here. And so 50% will be lower, 50% will be higher. Obviously, that's why it's the average, right down the middle. And what we're learning here is the standard deviation, 1 standard deviation out, is going to be 68% of the data set. 2 standard deviations out from the middle, you're going to have 95% of the data set. And 3 standard deviations out, you're going to have 99.7%. So really just memorize those 3 numbers, 68, 95, 99.7. Maybe picture this as well so you can understand what's going on. But that should be enough to get you a quick point or 2 on the test. Now, in order to understand the last topic of the video, which is combinations and permutations, we need to understand factorials first. The symbol for a factorial is this exclamation point. For example, this would be read as 5 factorial, and it equals 5 times 4 times 3 times 2 times 1. If it were 9 factorial, then it would be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So keep this in mind while we're introducing this next section. Combinations and permutations. First we'll hit permutations. The best way I've found to learn about combinations and permutations is straight up through examples. So we have 5 people running a race and we want to figure out how many different scenarios or permutations we could have to make up the top 3 places, first, second, and third. So whenever doing these questions, you always need to ask yourself, does order matter? If the answer is yes, then we're doing a permutation. If the answer is no, it does not matter, then we're doing combinations. I'll talk about that more in a second, but that's just something for you to think about and remember. So for this one, we have 5 people, A, B, C, D, E, and we're trying to figure out how many different ways that we can put these 5 people into first, second, and third. So we don't care about fourth or fifth in this situation. How many scenarios could we have to make up the top 3 positions? And the way that we know that order matters is because A being in first and A being in third is not the same thing. So because we care about the order, we use the permutations equation. And here is that equation. N factorial all over n minus k factorial. N is the number of total items that there are. So we've got 1, 2, 3, 4, 5. So n equals 5. K is the number of items we are selecting for. In this case, they're selecting only 3 of the runners, first, second, and third. So n equals 5, k equals 3. Now let's plug in the numbers, and we get 5 factorial over 5 minus 3 factorial. Simplifying that down, we get 5 factorial over 2 factorial, and then expanding that out, you get 5 times 4 times 3 times 2 times 1 all over 2 times 1. Oftentimes we can simplify problems so we don't have to go all the way down and do all the math. In this situation, you might notice that we have 2 times 1 on the top and the bottom of a fraction, so let's eliminate them. Now we just have 5 times 4 times 3. 5 times 4 is 20, and 20 times 3 is 60, so our answer is 60. And that tells us there are 60 different ways that we could have these 5 racers make up first, second, and third place. So for example, A is in first, B is in second, C is in third. A is in first, B is in second, D is in third. A is in first, B is in third, C is in second. You can organize this in 60 different ways. Now let's do one where order does not matter. This introduces combinations. You may notice it looks very similar to the permutations equation. It just has an extra k factorial in here. That's it. So let's say that I'm selecting 4 students to become TAs for my DAT prep course. I have 8 students that qualify for the position. How many different selections of students could I make? The first thing that you should ask yourself for any of these questions is, does the order matter? No, because whether you're the first person I picked to be a TA or the 4th person I picked for the TA, you're still a TA. Doesn't make a difference. That is when we use the combinations equation. Now, think about what you learned about permutations and what n and k represent. What numbers should we plug in for those values? N is the total number available, right? So that number is 8 because there's 8 students that qualify, and I'm only picking 4, so k would be 4. So there it is, we plugged it all in. Now let's just simplify it down. We get 8 factorial over 4 factorial times 4 factorial. And expanding that out, we get that mess. But remember, we're going to reduce this down. So first, let's get rid of that 4 times 3 times 2 times 1 on the top and bottom. Now we're left with this, and we can actually simplify this further. I know that 4 times 2 is 8, so let's get rid of those. Now we have something more reasonable to work with, and much less math is necessary, which means much lower chance of making silly mistakes. And that gives us 210 over 3, which equals 70. There you go. All right, practice problem number 1. Now that you know the basics of permutations and combinations, try this practice problem by yourself. And after this problem, I'm going to teach you the trickiest thing that they could really ask you about combinations and permutations. But let's get through this one first. How many ways are there to arrange the letters dental, D-E-N-T-A-L? Remember, the first question you need to ask yourself is, does the order matter? Yes, the order matters because D-E-N-T-A-L is not the same as D-N-E-T-A-L. So the order matters. We use the permutations equation. N is the total number of letters, which is 6, and K is the number of letters we are selecting, which is also 6. So both N and K are 6. That gives us 6 factorial over 6 minus 6 factorial, and this introduces something we haven't talked about yet. 6 minus 6 factorial is 0 factorial. 0 factorial equals 1. And that's just something for you to commit to memory. So we end with 6 times 5 times 4 times 3 times 2 times 1 all over 1, which gives us 720. All right, let's talk about the one thing that we haven't discussed yet with these, which is what happens when you don't have a straightforward combination or permutation problem like this one. For this one, we're asked to arrange the letters in a word again, so order matters, but we have 2 E's, so we'll call them E1 and E2. The order of E1 and E2 doesn't matter. Whether the first E is in the 3rd position or the first E is in the 5th position, it's the same thing. So it's just a little trickier. The way that we take care of it, though, is simple. We just divide out the redundant letters in the equation. First off, because order matters, we do use the permutations equation. And for n, the value of n and k are both 9 again. So we will end with 9 factorial over 9 minus 9 factorial, which will equal 9 factorial over 0 factorial, which will just give us 9 factorial. There you go. Now we account for the redundancies, the 2 E's. We take that 9 factorial and divide it by the number of redundancies factorial. So in this case, there's 2 E's, or 2 spots that are redundant, so we divide 9 factorial by 2 factorial. If there were 3 E's in this word, then we would just divide it by 3 factorial. If there were 2 E's and 3 T's in the word, then we would divide it by 2 factorial times 3 factorial. Here's what we get when we expand out the factorials, and we can eliminate the 2 times 1 on both top and bottom. And then after plugging that beast in a calculator, we get the final answer of 181,440 ways to arrange the letters in the word predental. So the DAT probably wouldn't use as long of a word as predental, but they could totally use a word with a double letter in it. So just make sure you understand how to do that and why we divided by 2 factorial versus when we would have done 3 factorial or something like that. All right, take a picture of the summary slide, and I'll see you in the next one.